Hello everybody! This is the first of our video solutions to Quiz 10 from Fall 2023, Math 307 Linear Algebra at Cal State Fullerton. And we have a four-dimensional complex vector space V and a linear operator T that has 0 as an eigenvalue. We also are told that we have a basis V1, V2, V3, V4 for the eigenspace corresponding to 0. We want to find the matrix of the operator in terms of this basis. Now, what does that even mean here? Like, we just had a basis for the eigenspace, so how are we supposed to find a matrix for T in terms of a basis that's not for the entire vector space? Well, let's look carefully. The vector space V is four-dimensional. We have this basis which has four vectors. So even though we're saying that this is a basis for the eigenspace, ET0, we know that the eigenspace, ET0, is a subspace of V, but the dimension of the eigenspace is 4, because look, it has a basis of length 4, but V also has dimension 4. So when you have a subspace with the same dimension as the entire space, we know that the subspace is equal to the entire vector space. So actually, I was just being a little bit tricky here, right? I said it's a basis for the eigenspace, but it's actually a basis for all of V. So it makes sense, right? I can write down the matrix for T with respect to B, and this is going to be a 4x4 matrix. We'll index it with V1, V2, V3, and V4. And we'd like to know what this matrix is. All right, well, let's see. We know that each of the elements, V1, V2, V3, V4, is an element of the eigenspace, which means they are all eigenvectors. That means we have a basis of eigenvectors, right? So B is a basis of eigenvectors. Now, they're not corresponding to distinct eigenvalues. Notice the eigenvalue is 0 for every single one of these. That's okay. When you have a basis of eigenvectors, we know we get a diagonal matrix if we write the matrix with respect to that basis. So this tells us that the matrix of T with respect to B is diagonal. So immediately, I'm going to be able to put zeros everywhere other than the diagonal. So I just have to figure out what the diagonal is, and I'll have zeros above and below. But actually, what do we know about the diagonal? That's going to correspond to the eigenvalues, but there's only one eigenvalue. They're all 0. So in fact, we get 0 everywhere along the diagonal as well. So in fact, M of TB is the 0 matrix. See you next time.